4.2 triangle congruence conditions. We're going to use triangle congruence conditions to show triangles are congruent. So recall, if we have the two segments are marked congruent as shown by these tick marks, that shows that those two segments are congruent. The tick marks show that segments are congruent. Or angles, we show angles are congruent by having the same number of arc marks. If I have one arc mark in each one, they're congruent, or if I had two arc marks in each one, we could say they're congruent. Just have the same number of arc marks. Another way to do that is put a tick mark on the arc, like that. One tick mark, you would just have one arc, so we could put a tick mark on the arc. That shows they're congruent. Congruent triangles. Triangle ABC is congruent to triangle DEF. That's written as triangle ABC congruent to triangle DEF. Don't just put the letters, put a triangle symbol in front of them to say triangles are congruent. Okay. Under the correspondence where A corresponds to D, B corresponds to E, and C corresponds to F. I know those points, those vertices correspond because of the order of the letters. If A is the first letter in the first triangle, and D is the first letter in the second triangle, that means A goes with D. B corresponds to E, C corresponds to F. The order of the letters matters. Okay, that's how you match up the corresponding parts. So, according to our congruence definition of triangles, all three pairs of corresponding angles are congruent, and all three pairs of corresponding sides are congruent. So all six parts of the triangle have to be congruent as we have it defined now for the triangles to be congruent. That's what it would look like if I marked the two triangles to show they're congruent. The following relationships follow from the definition. Reflexive property. Triangle ABC is congruent to itself. Triangle ABC. That's reflexive. Symmetric. Triangle, we say if triangle ABC is congruent to triangle DEF, we can say triangle DEF is congruent to triangle ABC. You are never going to use symmetric property as a reason in our proof. It's just, I don't see there much use at all for symmetric property. You're just reversing the order. But for some reason, students like to use that in proofs. You're never going to, I don't think there's any proof that I'll give you that you have to use symmetric properties. So don't think that's something you're going to use. The other two you will use a lot. Transitive and reflexive are used a lot. But a symmetric property is not used as reasons in a proof. You just need to know what it is. The transitive property, we've had it before. Now we apply it to triangles. It's a chain. If ABC is congruent to triangle DEF and triangle DEF is congruent to GHI, then we can say that ABC is congruent to GHI. Triangle ABC is congruent to triangle GHI. Another way to think of it is ABC and GHI are both congruent to the same thing, so they have to be congruent to each other. That's transitive. Transitive is a type of substitution, but it's more defined than substitution. It involves three things. Substitution, you can do substitution with just two things. Transitive or substitution sometimes with four things, but transitive always involves three things. Decide if the following pairs of triangles are congruent under implied correspondences. All right. So, do you think ABC is congruent to triangle QRP? Well, they are. Let me show you why. So for A, we've got triangle ABC is congruent to triangle QRP because angle A is supposed to go with angle Q, and they both have one arc mark, right? So angle A is congruent to angle Q. And then angle B is marked congruent with angle R. They both have 3 tick marks, right? Or 3 arc marks. So angle B is congruent to angle R. And angle C has 2 arc marks. It's congruent to angle P. So far, all the angles match up. Now let's see about the sides. Is AB congruent? AB would correspond with QR. The first 2 letters of ABC, AB, should be the same length as the first 2 letters of QR. So AB is congruent to QR. Right? And BC is congruent to, should be congruent to RP, and it is. It's 6 and 6. So BC is congruent to RP, and the last one, AC, is the last side. It should be congruent to QP, and they are, AC is 8 and QP is 8. So AC is congruent to QP. Any questions? Everybody get it? So we showed all 6 parts are congruent. Let's do the next one. GHI, is it congruent to JKL? Is GHI congruent to JKL? What do you think? As named, are they congruent? Yes.
Yes, they are. Wait, no. Wait. No, they aren't.
Why not?
Because if you go into the order, angle-wise, they might be the same, and they could possibly be the same, but when you go sidewise, because in G and H, the distance from G to H, which is 6, has to be the same from the distance to J to K, which is 4.
Exactly. That's right. They might be congruent. The triangles might be congruent, but as named, he mentioned the order of the letters, right? As named, with the order of the letters as they are, the congruent parts don't correspond. So we would say B, triangle GHI is not congruent to triangle JKL because, for example, GH, which is 6, is not the same as JK, the first 2 letters of the second triangle. It's 4. So GH and JK are not congruent. Triangle GHI is congruent to what? What is it congruent to? How can we adjust the name? Yeah, go ahead, Hicha. So we would have triangle. Nope. Here we go. Triangle GHI is congruent to triangle. What'd you say?
LJK.
Not LJK. LJ is 3. And GH is 6. Abby. LKJ. LKJ. Then they match up. All right. Everybody got it? So we went through all that process to show the last two examples were congruent. Now, rather than have to show all 6 parts, corresponding parts are congruent, we're going to have some shortcuts. You only need to show 3 of the parts. 3 of the corresponding parts are congruent. So we're going to use shortcuts from now on to show triangles are congruent. The first one is the side-angle-side congruence postulate. 2 sides and an included angle of one triangle are congruent respectively to 2 sides and included of another triangle, then the triangles are congruent. That's side-angle-side combination. So included angle means if I have the 2 sides, these are my 2 sides, the angle between those 2 marked congruent sides is the included angle. That's a side-angle-side combination. I can't just pick any angle on the triangle. It has to be between the 2 congruent sides. So that's side-angle-side. And that's so if I can show a side, the included angle and a side in a triangle is congruent to that of another, then I can say the triangles are congruent without showing the other parts are congruent. So side-angle-side is one of our shortcuts. Another shortcut is leg-leg congruence. You can use leg-leg when you have a right triangle. If 2 legs of one right triangle are congruent respectively to 2 legs of another right triangle, the 2 triangles are congruent. Right? So we've got the right angles and both legs are congruent, then the triangles are congruent. Leg-leg congruence. What is this really? Yes?
That's why the Pythagorean theorem, because if you're saying that those 2 are the same, then that means both of their squares have to be the same thing as the final length square.
Okay, that's one way you could prove leg-leg. Yes, that's correct. What is this another form of? Yeah. Well, yeah, it'd be a 45, 45, 90, but this is also side-angle-side, right? It's side-angle-side. They just, so you could use either one here to say the triangles are congruent. You could say leg-leg, just write LL, or you could do side-angle-side, SAS. You just write the letters. Hypotenuse leg. Hypotenuse leg says if the hypotenuse and a leg of one triangle are congruent, right triangle are congruent respectively to the hypotenuse and the leg of another right triangle, the 2 triangles are congruent. So here's a case where you couldn't use side-angle-side. You've got the hypotenuse and one of the legs. It doesn't matter which leg as long as it corresponds to the other leg in the other triangle. Hypotenuse leg HL is another congruent shortcut. Any questions? Corresponding parts of congruent triangles are congruent. That's abbreviated CP. All right, so what that means is if I show 2 triangles are congruent by shortcuts, say I show that 2 triangles are congruent by side-angle-side. That means that there are 3 parts of that triangle, those 2 triangles we haven't shown are congruent. We've shown the side angle and the side combination. Those 3 parts are congruent, but the other 3 parts we don't know about. We haven't shown they're congruent. But because the triangles are congruent by side-angle-side, those other parts that correspond, we can say they are congruent. Right? even if we didn't have that marked in the beginning. That's when we use corresponding parts of congruent triangles are congruent, CP. Here we're going to use CP to show that angle P is congruent to angle S. So sub-goal 1, show triangle PQR is congruent to triangle STR. Sub-goal 2, show that P is congruent to S by corresponding parts. This is what it would look like. You can refer to the picture in your notes as we do the proof. So, step 1, PQ is congruent to ST. How did we know that? Shatiz.
It's congruent. I mean, it's given.
Yeah, it's marked. It's marked. You don't need to write this in the proof. I'm just writing it so you remember it. That's marked in the proof. What's my other given? Yes. Go ahead, Nina.
RT is congruent to RQ.
Okay, RT is congruent to RQ is given. What's another statement we could say? What would be my third statement? Madeline, what do you think? Nick, go ahead.
Angle Q is congruent to angle T.
Yeah, angle Q is congruent to angle T is given. So over half of this proof is just given statements. All you got to do is identify what's given and list it. And you've got over half the points of the proof. How do I know the triangle PQR is congruent to, and what is it congruent to, and how do we know that? Okay, Shatiz.
PQR is congruent to, so then it would be congruent to STR, I believe.
That's correct. He got the corresponding parts matched up. And what's the congruent shortcut we're using there, Shri?
I believe called the SAS.
Yes, it's side angle side. All right. We have two sides included angles in both, and it's SAS. And he named it correctly, STR. Now, so that's our first sub-goal. Our second goal is, how can we show that angle P is congruent to angle S? That's where we use CP, corresponding parts. They correspond in those triangles, and the triangles are congruent, so the parts are congruent. Angle P is congruent to angle S. You will never use CP to say triangles are congruent. So you would never use CP for your reason in step 4. And CP always has to follow triangles being congruent. It will never be before triangles being congruent. And that's a common error with CP. People use it to show triangles are congruent. That doesn't make sense. It's talking about parts. And you can't use corresponding parts until you have shown triangles are congruent. So somewhere above the CP step in your proof, you have to show that the triangles are congruent. Another congruence postulate is angle side angle. Now the side is included between the two angles. You've got two angles. The side is included. It's in between the two congruent angles. The congruent side is for angle side angle. Let's do an example with angle side angle. We've got in the figure, it's a good idea to mark the figure as with the given thing. So angle A is congruent to angle D. AC is congruent to DC. We're going to prove that AB is congruent. I'm not going to mark what I have to prove. I wouldn't mark that. So we have to prove that AB is congruent to DE. I I go ahead and mark the other thing that's congruent in the figure, then you basically do the proof by marking your figure, then you just have to list the steps. What else could we mark congruent in these two triangles? What else do we have? Let's hear from someone else. What do you think, Ben? What else could we mark congruent? Chris?
ACB and ECD.
Yeah, what are they? Well, yeah, but what kind of angles are they? What do we call them? Yeah. So we could mark these two. We could mark this angle congruent to that angle by vertical angles. So now what type of congruence do we have? Caitlin? I don't have two sides marked. Couldn't be side angle side. Go ahead. Yeah, that's angle side angle. So we've basically done the proof just by marking the figure. Now let's do the steps. So it's a statement, reason, proof. So now when you do a statement, reason, proof, you need to number both your statements and your reasons so that you can tell what matches up. Because sometimes the steps get, they don't match up horizontally. So I'll number both your statements and your reasons. It will be a deduction on a test if you don't number your steps. So the first thing we had given was that we had the angle A is angle A is congruent to angle D, and that's by given. Step 2, we had the other given that AC is congruent to DC, and that's given. And in step 3, what would be my third step? Tease?
Angle BCA equals angle ECD.
Angle BCA is congruent to angle ECD. And how did we know that?
Vertical angles.
Yep, that's VA, vertical angles. Step 4, what would be my next step in the proof? Chris? What's that? Okay, let's name them. Name the triangles correctly.
ACB equals BCB.
Okay, so we could say triangle ACB is congruent to triangle DCE. He got the corresponding parts matched up there when he named it. And how did we know that, Chris? Which shortcut is that? What's that? Yeah, angle side angle. All right. So then our last thing in our proof is always going to be what we had to prove. So we're going to prove that AB is congruent to DE. How do I know that? Ben? Yeah, that's where you use CP. So that would be CP. Questions? Shatice?
So I'm wondering that, so if we have two angles given, if we know that if we have two angles, then we use ASA, and if we have two sides, we use SAS?
Well, there's going to be another one, I think it's in this section. There's another time when two angles are congruent that you would use a different shortcut. It would be angle, side. There's an angle, side we can use. And then you will never use SSA. That is not a shortcut. SSA or ASS. Either way, whichever order you do it, okay? And you just think of it. I would not allow you to write ASS on a quiz, right? So you can't use that one. That's out of bounds, all right? It's no good. It's not a shortcut. Another shortcut is side, side, side. So we have the side, side, side congruence postulate. It just says that all three corresponding sides are congruent. Let's do a proof that uses side, side, side. So we have this. This is a kite. We're going to prove angle A is congruent to angle C. And you can see they added a line and they said it is congruent to itself. How would we know that line is congruent to itself? How is something congruent to itself? What do we call that? Yes, Nick?
Symmetry.
No, it's not symmetry. We'll never use symmetry in a proof. Something is congruent to itself. What is that? Shatice?
Reflexive.
Reflexive. All right, so let's do the proof. Statement 1 was our given. A, B, C, D is a kite. And that's given. Step 2. What do we know from that being a kite? It's already marked in the figure, but what do we know? Dina?
Line AB is like congruent. I mean, yeah, congruent to line AB.
Line AB is congruent to what?
Line BC.
BC. All right, and what other lines are congruent? Because it's a kite. Julia?
AD and
AD is congruent to DC. And that's by definition of kite. I know those things. Okay, then we added this line BD. Anytime so we draw in BD. Anytime you draw in a line or something to add something to a picture, that's the postulate of whatever you drew. So that's the line postulate. Because we have 2 points. When we connect 2 points, it makes a line. That's the line postulate. So we added that by line postulate. And then we want to say that it's congruent to itself. BD is congruent to BD. We already said that's reflexive. What would be my next step in this proof? What's the next thing I would say? Yes, Zachary.
Triangle BAD is congruent to triangle BCD.
Triangle BAD is congruent to triangle BCD. And he got the order right. That's by what, Zach?
SSS.
That's SSS. And then what's my last thing? What would I ended up with? What did we have to prove? Shatiz?
Angle A is congruent to angle C.
Angle A is congruent to angle C. How would I know that? Lexi? Yeah, by CP. We know that by CP. Questions? Yes.
So is CP saying that if like two sides were to be congruent, and the corresponding angle is congruent?
No, it says if two triangles are congruent, the corresponding unmarked sides or angles are congruent.
So for example, so like in this one, it would be like, so these two would be congruent because of corresponding angles because they're both corresponding to BD.
AC?
Mm-hmm.
Let me look at
Angle A and C.
angle A and C. Well, when we named the triangles, we named it triangle BAD was congruent to triangle BCD.
And then
A is the second letter, C is the second letter. So that means those two angles correspond. They weren't marked. We weren't given that. We didn't know that. But we know it now by CP. Because the triangles are congruent, we know those that A and C.
two triangles, so it's trying to say that two triangles are congruent, like in the letter order that they're in, the like corresponding one to the naming would be the same.
That's correct. All right, we've got one more proof. The converse of the Pythagorean theorem. So the converse of the Pythagorean theorem says if the sum of the squares of the lengths of two sides of a triangle equals the square of the third side, then the triangle is a right triangle. Pythagorean theorem says if you have a right triangle, then it's just the converse of that statement. So we are proving the converse of the Pythagorean theorem. We're showing we have a right triangle. So we're going to prove that. So we're given ABC with a squared plus b squared equal to c squared. We're going to show that c equals 90. So here's how our proof would work. So we have step 1. Angle F is equal to 90. And that's given. It's marked in the picture. Step 2. In the triangle ABC, we have a squared plus b squared equals c squared, and that's given. Step 3, a squared plus b squared equals de squared. That's by I've got my numbers out of order. This is step 3, step 3. That's by Pythagorean theorem. So we had one triangle we knew was right. DF we knew it was right. We're trying to show ACB is a right triangle. So we're using the right triangle on the right to show the one on the left is a right triangle. So we've got a squared plus b squared equals de squared. And then step 4 would be c squared is equal to de squared. So from that we can say c equals de. And that's by substitution. So now we can say, we've got all three parts corresponding, we can say that step 5, we can say triangle ABC is congruent to triangle DF, and that's by side, side, side. So step 6 says angle C is congruent to angle F, and that's by CP. And since we know F is 90, by substitution, the last step, I'll go up here to the top. Step 7, we know angle C equals 90 from our very first step, where we said F was 90. So that's by substitution. All right, any questions on the proof? Okay, that's all of section 4.2.